Now in this video I'm going to be giving you examples that will show us how to multiply matrices. Now if you have your two matrices multiplying each other, say matrix A multiplied by matrix B, the way we multiply is row by column. So we'll be taking a row from matrix A and we multiply that to a column on matrix B. So that is how we multiply our matrices. It's a row by column. From the first matrix, you take a row, you multiply that with a column on the second matrix. So it's a row from matrix A multiplied by a column on matrix B. So let's have an example. The first example is part A. We want to multiply the matrices 1, 2, and 3, 4. You can see here that I've got a row matrix in 1, 2 and a column matrix in 3, 4. So I've used this example to show you how we multiply a row by a column. Okay, so how do we do it? From the row, the first matrix, I take the first element and I multiply that with the first element in the column. So here I'll be getting 1 times 3. So I'll be getting 1 times 3. That's the first element in the row multiplied by the first element in the column. Next, I take the second element in the row, I multiply it with the second element in the column. So that's plus 2 times 4. And by so doing, I would have multiplied the matrices completely. So I now just simplify. So that's 1 by 3 gives us 3, and 2 times 4 gives us 8. So 3 plus 8 gives us 11. So our solution will come out as 11. So that's simply how we multiply a row and a column. Okay, let's look at example B so that we can really see how things are going. On B we have the matrices 1, 2, 3 and 4, 5, 6. We also have here a row matrix and a column matrix like we had on example A. So how do we multiply the row and the column? It's first element on the first matrix on the row and the first element on the column. So I'll start with 1 multiplied by 4. So it's 1 times 4, and the second element, that's 2 times 5. So it's plus 2 times 5. And we also add that to the product of the third element on the row and the column. So that's plus 3 times 6. Okay, and we can now just simplify this so that we can get 4 plus 10 plus 18. That's 3 times 6. And 4 plus 10 plus 18, the solution will come out as 32. So these are the two solutions we're getting for A and B. You can see that here that whenever we multiply a row matrix by a column matrix, we get a 1 by 1 matrix. Like on example A, we had a 1 by 1 matrix as our result, and on B we also have a 1 by 1 matrix as our result. That's the order of the result. So that's what we get when we multiply a row matrix by a column matrix. That's important for us to note. Alright, let me take you to a third example, example C. Alright, on C we have the product 2, 3, that's a 1 by 2 matrix multiplying a 2 by 2 matrix 3, 0, 1, 4. Alright, now remember what we said in our introductory video, that it is possible for us to determine the order of the result simply by checking the order, using the order of the two matrices being multiplied. Like here I'm saying that we have a 1 by 2 matrix multiplying a 2 by 2 matrix. These two numbers we say should be the same if the two matrices can be multiplied, and the result will come out in this case will be given by the two order values, so it will come out a 1 by 2 matrix. So I now know the order of the result, so I can safely multiply the two matrices, right? And it's row by column, right? So it's a row from the first matrix, so this row multiplying in the first, because on the second matrix we have two columns, so I'm gonna multiply both columns with this row that we have on matrix A. So I'm gonna start with the row multiplying the first column right here. So I'll be multiplying 2 times 3 plus 3 times 1, right? So I've done it like I was doing it on A and B. First element times first element plus second element times second element. So the products here added will give us those two, will give us the solution for the row and the column. So that's 2 by 3 plus 3 by 1. And next I'm going to multiply this row by the second column. So that's 2 times 0 plus 3 times 4. So that is the row and the second column right here. And I can now simplify, so that I'll be having, in this case I have 2 times 3 plus 3 times 1. So 2 times 3, that's 6. 6 plus 3 will give us 9. So that's what we get right there. And next I also simplify here. 2 times 0 gives us 0, and it's 0 plus 3 times 4, that's 12. 0 plus 12 gives us 12. So our solution, the matrix, will come out as 9, 12. And you can see here that it's really a 1 by 2 matrix. So that's the order of our result, which we have obtained. That's 9, 12. Okay, let's go on to the last example, D. On D we have here a 2 by 2 matrix, negative 2, 1, 0, 3, and a 2 by 1 matrix, 4, 5. Alright, so that's a 2 by 2 matrix multiplying a 2 by 1 matrix. The two values are the same. Perfect. The result will come out a 2 by 1 matrix. Okay, so having that in mind, we can multiply. You can see here in this example that on the first matrix we have 2 rows, and on the second matrix we have 1 column. So the 2 rows in the first matrix are all going to multiply the column in the second matrix. Remember, we said we multiply row by column. Row from the first element, column from the row from the first matrix, and column from the second matrix. So I'm going to multiply, starting with the first row, multiplying this column. So I'll be multiplying minus 2 times 4 first elements. So that's minus 2 times 4 plus 1 times 5. So that's plus 1 times 5. Right? So I'm through multiplying the first row and the column. Next I'm going to multiply the second row, the lower row, by this column. So it's going to be the first element times the first element. So that's 0 by 4 plus 3 times 5 plus 3 times 5. So that's what we get right there. That's what we get when we multiply those two matrices. And we now just simplify. So negative 2 times 4 will give us 8. Sorry, will give us negative 8, right? So that's negative 8 plus 1 times 5 will give us 5. So negative 8 plus 5 gives us negative 3. And here, if we simplify, we have 0 times 4 get 0 plus 3 times 5, that gives us 15. So we get 15 right there. And our solution in this case will come out as negative 315, which is a 2 by 1 matrix that we were expecting. That's a 2 by 1 matrix. That's the result.